So we've already looked at two relationships. We looked at Boyle's law, which was pressure and volume, and we looked at Charles' law, which was volume and temperature. So now we're going to look at a law called the Gay-Lussac's law, which I like. This always makes me happy and gay. Yay. All right, the Gay-Lussac's law states that for a fixed amount, again, of gas, at constant volume this time, the pressure of the gas is proportional to the Kelvin temperature. So just like the volume was proportional to the temperature, so is the pressure. And that makes sense because we know that pressure and volume go together. As one goes up, one goes down, right? Okay. All right. So if we increase one, the other increases. And here's our constant relationship that we saw written in a similar way to the other laws. And so what happens, and according to Gay-Lussac, that was two different dudes, but we just put the name together because they work together. Increasing the temperature increases the kinetic energy of the gas particles, causing the pressure exerted by the particles to increase. So basically we heat them up, and I always use the analogy of if you've ever been to the beach and you are walking in the sand and it's hot and you've got your flip-flops off, it is hot as blazes, isn't it? And so you are going to walk very, very quickly until you can put your flip-flops back on. And so because of that heat, it's hurting you and making you move faster. So the increase in temperature also makes these particles of gas move a lot quicker, and they're just bouncing off the walls trying to get away. And so that causes them to hit harder against the wall, if you want to imagine that, thus increasing the pressure that they're exerting. Okay, and so if you have start out with an atmosphere pressure in 2 liters, you are going to increase the temperature, you are going to increase the pressure, and you're going to increase the volume. And so that's basically what Gay-Lussac is saying. And so P1 over T1 gives us P2 over V2. So all three of these gas laws can be combined into one, what we call combined gas laws. And the combined gas law says that P1 V1 over T1 is going to be equal to P2 V2 over T2, where 1 are the initial conditions and 2 is the new conditions. And I had a professor in the beginning of my career as a chemist tell me this, and I've never forgotten the relationship, and so I'm going to share it with you. And that is that pigs vomit over troughs. You've never been to a pig farm, you can't really relate to this. I grew up very young and escaped as quickly as I could. But pigs vomit over troughs is just a visual you can't get out of your head. And so a lot of times those will help you remember. So PV over T equals PV over T. So pigs vomit over troughs. This equation can be used to calculate any of the problems that we were talking about, any calculations. If one of them's constant, you just ignore it. So if I said at constant volume, then you just say, okay, volume's constant. They would cancel each other out anyway. And so I use P1 over T1 equals P2 over V2. If I wanted to just, do pressure and keep volume and temperature. So you can use those as long as you know several things, then you can solve for one. And this allows us also to change more than one factor. So instead of just increasing the pressure, I could calculate what happens if I increase the pressure and the temperature. All right, so just a summary of the gas laws that we've talked about so far. Boyle's law, which is as pressure increases, volume decreases, or P1 V1 equals P2 V2. And we have a constant temperature and amount. Charles' law, which says as temperature increases, volume also increases, as long as you keep the pressure and the amount constant. The Gay-Lussac law, P1 over T1 equals P2 over T2. As T increases, P also increases, as long as the other two, volume and amount, are kept constant. And then our combined gas law, which combines all three into P1 V1 over T1 equals P2 V2 over T2, and this shows us the relationship that we can use to work problems.